All right, so today we're talking about how to find the area of a regular polygon. So I'm just going to rehash some old stuff that's really going to be all we're going to use to find the area of a regular polygon. So first you need to be able to find the area of a triangle, okay, 1/2 base times height. And then specifically there's two situations that come up a lot. If you have an isosceles triangle where you have all the side lengths, you'll have to be able to find the area of that. Or if we have, oh, and I forgot one little mark, if you have an isosceles triangle where you have an angle measure and a single side length, you should be able to find the area of that, okay? So let's look specifically at how we would do that. So if we have all three sides and it's an isosceles triangle, we know we can draw the perpendicular bisector straight down. So that's going to be a right angle on both sides. It's going to cut this in half. So we have a side of 3 and a side of 3, okay? And anytime we have an isosceles or equilateral triangle, we're able to do that. Cut it down that line of symmetry and get the same information on both sides. That cuts the top angle in half. These base angles are congruent. That bottom side gets split in half, and we have those 90-degree angles. Okay, so if we want to find the height of this, because we know the area is 1/2 base times height, and we know the base is 6, so this is 1/2 6 times, and if we could just find the height, we're done. So what we need to do here is off to the side, and I'll do it in a different color, is I'll say, well, look, we've got a right triangle here. Here's this thing right here is a right triangle with a 3 and a 10 and a height. So we just go ahead and use the Pythagorean Theorem, and so we're going to go 3 squared plus h squared is 10 squared. With a little bit of algebra, we get that the h is square root of 91. And so down here, we get that the area of our triangle is 1/2, the base of 6, times that new height we found using Pythagorean Theorem of square root 91. So switching back to orange, we get that the area is 1/2 of 6 is 3. So we get 3 root 91. That's our area of this. And again, you can put it into a calculator and approximate that if you like. Okay, so this other one, again, we're going to use the same steps. So our big strategy on the first one was step 1, we will cut it in half. And the second step was we'd use Pythagorean Theorem to find the height. Okay, in the second one, we're going to use very similar steps. We're still going to cut it in half first, okay? And after we cut it in half, what we end up getting is, so dropping this down, we get 2 right angles. This gets split, so we have a 6 and a 6. We still want to find the height, but now in our triangle, pulling it off to the side, look at what we have. And again, base angles are congruent, so I know it's an 80 on both sides. So what we have is a right triangle with an 80-degree angle. So of course we could find the other degree is 10 just by subtracting from 180. And we know that the base here is 6, and we're looking for the height. So this is exactly what trig was defined to do, right? We have a right triangle. We have all the angle measures. So we know the ratios of all the sides. And as soon as we have that one side length, we could find all the others. So the second step when we have an angle is instead of using Pythagorean Theorem, we're going to use trig to find the height. Okay, and we already knew the area of this, right? We could start and say, well, the area is 1/2 base times height, and the base was given, so it's 1/2 12 times. If we just find that height, so what I'm going to do is in green off to the side, I'm going to say, okay, well, in this triangle, we've got the tangent of 80 degrees is equal to the ratio of h over 6. So if we multiply both sides by 6, because the 6 is on bottom, we get that the height is 6 times the tangent of 80. And so down at the bottom, we put that in here, 6 times the tangent of 80. And now if it asks for an exact answer, we could just simplify that, or you could plug it into a calculator and get an approximate answer. So 1/2 of 12 is 6, and then 6 times 6, this would be 36 times the tangent of 80 degrees. And again, you could plug that into a calculator to figure out an approximate value. So isosceles or equilateral triangle, we're going to first cut it in half, and then we're either going to use Pythagorean Theorem or trig to find that height. And this is going to be really common. These two situations are going to rise a lot as we're looking at finding the area of a regular polygon. And in general, this is going to be where the difficulty lies. This trig or Pythagorean theorem is going to be the hurdle to get through. And beyond that, actually finding the area of the rest of the shape is pretty straightforward, okay? And the reason is, if we're looking at a regular polygon, the first step we do is we say, well, let's just cut it up into a bunch of congruent triangles. We've got rotational symmetry. We've got all the sides are the same. All the angles are the same. So on the left here, a 5-sided figure, we cut into 5 congruent triangles. In the middle, a 6-sided figure, we get 6 congruent triangles. An 8-sided figure, we get 8 congruent triangles. And so if we want to find the area of this shape, it's simply the area of a single one of those congruent triangles times the number of triangles. And often this is all you need to know to be able to find the area of your shape. And I think honestly, people would be better off if they had this more conceptual understanding rather than a formula to go right to, because too often people just plug the wrong numbers into the formula and they're like, but I used the formula, it's right. And instead, I think having this conceptual understanding of, let's just find the area of a single one of these triangles, right? So let's just find this area of this triangle right here in the hexagon, and then let's multiply it by 6, right? And as long as you can do that, I mean, this is stuff we did a long time ago. If you can find the area of these 2 triangles I talked about in the kind of review portion, then you just multiply it by 6, or you multiply it by 8. You just multiply it by how many sides there are in the shape, right? So it's the area of a single triangle times the number of triangles. So just looking at that formula, though, let's rework it a little bit, okay? The area of one triangle is 1/2 base times height, and the number of triangles, well, that's the same as the number of sides, right? There's 8 sides, there's 8 triangles. 6 sides, 6 triangles. But think about that, okay? Looking at this, if we have the base, which is a length of a single side, right over here in the picture, right? This is the base of one of the triangles, okay? So we have a length of one of the sides times the number of sides. So the length of a single side times the number of sides, that's going to give us all the side lengths all added together. So what's that give us? If I take this length and multiply by 6, that's going to be here, 2, 3, 4, 5, 6. So multiplying that base times 6, since it's regular, all the sides are the same, that is exactly the perimeter. So if we rearrange this just 1/2 times, and I'll switch the base and the height because they're multiplication. The order doesn't matter. So 1/2 times height times that single side length times the number of sides. Well, that portion right there is just the perimeter of the polygon. So the formula we use is simply the area of one of these regular polygons is 1/2 the height of one of these triangles. I wrote that right here where the h represents the height of one of these single congruent triangles. And over here in the picture, I showed you what height I'm talking about, that pink h there, okay? And then the p represents the perimeter of the total polygon. Okay, so that's our formula. And I wouldn't box that yet because I'm actually going to swap out that letter H for a little more clearly using a letter A, and I'll tell you why. The reason is the height would, just in general, if I'm talking about a polygon, I use the lowercase h for the height, I would be talking about the height of the polygon, right? If I set the polygon on the ground, what is the tallest point? And since this is parallel to the bottom, it's an even number of sides, the height would be this length right here. Right? The top of the polygon to the bottom of the polygon would be the height. And that's a little unclear. I'm talking about the height of a single triangle. So we have a separate vocabulary word we use. Mathematically, this is it. That's the area of a regular polygon right there. Or, more generally, the area of a single triangle times the number of triangles. Okay? But the word we're going to introduce here is simply the apothem. Okay, so what the apothem is this the height of one of those single triangles, okay? So the single triangles we were looking at, the height of one of those is called the apothem. The apothem is the line segment from the center of a regular polygon to the midpoint of any side. So I showed you 2 different ones. Here's one apothem. Here's another one. I could draw, I could add more in a different color. Here's another apothem, right? It splits this one in half. I'm using the same tick marks because this is a regular polygon. So all the sides are congruent. So half of a side is always congruent to the other halves, right? And so I could add apothems to every single side, right? But all we need is one, okay? So here's an apothem. So Now our formula, once we introduce that single word of what an apothem is, the distance from the center straight perpendicularly at a side, which is the midpoint of a side. Now our formula is 1/2 that apothem, or the height of one of the single triangles, times the perimeter of the shape. Okay, again, you could either use that formula, or I think just as good as the area of one triangle times the number of triangles. I think that one is possibly a better formula to remember. Okay, so let's go ahead and actually find some areas. Okay, so that's kind of the lesson portion over. Let's just jump into some examples. So it might be as straightforward as they give you all the information you need. So here we go, looking at this. Well, here's the center of my regular polygon. So I know that the apothem in here, right, that this perpendicular in an isosceles or equilateral triangle, this cuts this in half. We get this is 6 on both sides. Okay, so the apothem in this picture is 2√3. Now the perimeter of the shape is, since it's a regular polygon, it's 12 plus 12 plus 12, or 12 times 3 is 36. So the area of this triangle is simply 1/2 the area, or not area, 1/2 the apothem, which is 2√3, times the perimeter of the shape, 36. Now 1/2 times 2 cancels out to 1. So we have 36 times √3. So the area is 36√3. And again, you could plug that in the calculator to get an approximation. Okay, what's really happening here is we're splitting this up into 3 triangles. And we're finding the area of this one triangle on the bottom, and then multiplying it by 3. That's what the formula is doing, just to show you why the formula is working in this case, even though it is already a single triangle. Okay, so over here on the right, we've got an apothem, right, to the midpoint of the side. We've got this apothem is 2.5 in length. The perimeter we don't have. So I know already the area of this shape is 1/2 times the apothem times, I just wish we had that perimeter. So let's go ahead and figure out this perimeter somehow. So zooming in here, whoops, I've got, I'm going to switch this a little bit. So I want the perimeter. Well, I know there's 1, 2, 3, 4, 5, 6, 7 sides. Okay, if I could have just a single side length, I'd have the total perimeter. Well, and the side on the bottom is split in half, so if I could just find this, then I could multiply that by 2 to get a single side, multiply by 7 to get the total perimeter all the way around. Oh, but look, if I draw this, what I've got here is I've got x and 2.77 and 2.5, where this x represents 1/2 of a side. So I could use Pythagorean Theorem here, so I could get, okay, so x squared plus 2.5 squared equals 2.77 squared. So I could just, rearrange this. So I'd subtract the 2.5 squared from both sides. I get x squared equals 2.77 squared minus 2.5 squared, or x is whatever the square root of that is. So 2.77 squared minus 2.5 squared. So that comes out to be 1 point something. Now, I have 1/2 of a side going back up here in green. Okay, so I've got this x value. Okay, so I've got this 1/2 of a side. So what I do is I take this x up here, and the perimeter that I'm going to plug in is, I'm going to plug in, well, 2 times x, that's one side. Okay, so that's one side. And then I'll multiply that by 7 sides. So my total area of this shape will be, well, I already have 1/2, the apothem is 2.5, and then I get that my perimeter is 7 sides, where each side is 2x long. Okay, and whatever number I get there, I'll plug in. So I could do that off to the side. I could say, well, oh, look, I've already brought it up. So there's the square root of 2.77 squared minus 2.5 squared. So I take that number, and I'm going to say, okay, well, that number is my x value, 1 point, X is around 1.192. So going back up here, I get this is, and now I'm dealing with an approximate value. So I'm going to take that number, and I'm going to say, okay, we'll multiply it by 2. Okay. Then I'm going to say, okay, well, take that and multiply it by 7. So here's the perimeter of my shape. Right? Oh, sorry, 7 point. That's not what I wanted. I wanted 7. Sorry, get rid of that. I wanted, oh my goodness. Let's just get out of there. Okay, sorry. So we've got 1/2 times, oh, it's the decimal, that's right. Okay, so 1/2 times 2.5 times 7 times 2 is 14 times 1.192, and this is what I end up getting. So 19 point, oh sorry, there's a, let's get rid of that, 1.192. So then we end up getting 20.86, so around 20.86, just the approximate value. Okay, so now let's do another couple problems. Okay, so we already saw that sometimes we won't have a side, sometimes we won't have a perimeter, and finding that part of a side or finding that entire side is going to be where the meat of the problem is. But there's another thing that comes up really often is you don't even need to be given those 2 side lengths. If this is a regular polygon, we could actually figure out, so in a 10-sided figure, so I'm going to do a terrible job here, but if we have a 10-sided figure and ... okay, it's asking from the center, what would a central angle be to here? And this has to be a regular polygon. But if it's a regular polygon that has 10 sides, we could find a single angle. We could just say, well, I know total in the whole circle is 360 degrees. And I know there are going to be 10 congruent triangles around this shape. So I take my 360 degree total divided by 10 triangles, and I get that it's 36 degree angle in each. Now this is going to be really useful because if I, just blowing this up, that was my answer. If I blow this up and say, okay, so I've got this polygon here, right, ... right? Obviously that's not going to be a 10-sided figure, but if I've got a 36 degree angle here, and this is a regular decagon, well, I know this is an isosceles triangle then, because just rotational symmetry, that's the same length there. What I could do is I could split this in half and say that's 18 degrees on each side. That's half of 36. And now that's enough information using trig, and just if I was given a side length like 16 inches, I can now use trig to say, well, here's 8 and 8. The 18 and the 8 is sufficient information to find that height. So I could just have been given a regular 10-sided figure with a single side length of 16 or a whole perimeter of 100. And I could, using that central angle that I found to be 36 degrees, that's all the information I need to use some trig to find the apothem. And so as I mentioned, this is going to be the harder part, that Pythagorean theorem or that trig. Okay, so going over here, another one, if I have a regular 24-sided figure, again, I'm just drawing a couple random sides and saying ... one of those central angles of this shape is going to simply be 360 degrees total in a whole circle here, and then divided by 24 triangles. And I end up getting 15 degrees in each. Whoops. Okay. So now let's put those together, okay? Let's go down and do a couple problems here. Now this is where it's going to slow down. I'm going to do lots of examples. So for the first one, it tells us that this is a regular polygon. Find the perimeter and the area, okay? So again, this is the hard part. What I've got, just drawing in this other length here, I've got an isosceles triangle where this is 20 and this is 20. But I actually have more information because there's 1, 2, 3, 4, 5, 6, 7, 8 sides. So if there's 8 sides, then I have 360 degrees divided by 8, which is, what's that, 45 degrees each? Yeah, so 45 degrees. So I know that this is a 45-degree angle. That's what I'm starting with. 8-sided figure, I know the central angle, so I've got my isosceles triangle that is 20, 20, and 45 degrees. Now this is bringing me back. That was all the new stuff. Now looking at my original thing, I've got an angle and some side lengths. I can use trig to find the area of this, multiply it by 8 triangles. So it all comes back to these 2 types of triangles we had at the beginning. Okay, so let's go back down. Okay, so let's see. First things first, I'm going to use a different color. I want to cut this triangle in half. Okay, I've got this angle right here is a right angle. This is split in half. This is half of 45, or 22.5 degrees on each side. So I need to find both the height and the base here. Let's call this x and this h. Okay, so what is this, 22.5? So I know the cosine of 22.5 is equal to h over 20. So multiplying by 20 on both sides, I get that the height of this, or the apothem of my shape, is 20 times cosine of 22.5. Okay, so that's 20 times the cosine of 22.5. Ooh, my writing is not so good. Oh, they read it perfectly. So 18.477. So 18.477. Okay, so that's my apothem. And then I'm going to look for x here. So x is sine of 22.5 equals x over 20. I'm just using trig with the triangle that looks like this. I've got hx 22.5 and 20. This is my triangle I'm using trig with. So now multiplying both sides by 20, I get that x is 20 times sine of 22.5. So going back over here, I've got, cross that out, this is now the sine function, and that's 7.653. So 7.653. Now I've got all the information I need to answer the question. So I'll switch colors here. It asks for the area and the perimeter. So the perimeter first would be, I have 8 sides, and x is half a side. So I'm going to say it's 8 times 2 times, and then that x, which is 7.653, right? Because 2 times x would be this entire bottom length of a single side. And so 2 times x gives me, around 15 being the length of a single side. And then times 8 is my total. So I'm going to say 8 times 2 times 7.653. So that's 122.448. So 122.448. And then the area of my shape is simply 1/2 apothem perimeter. So 1/2, and then my apothem is 18.477 times the perimeter, which is 122.448. Okay, so that's 1/2 times 18.477 times 122.448. There we go. Oh, I forgot a decimal there. Let's hold on. That's 122.448. Let's try that again. There we go. So let's round that off to a nice whole number, 1131. So area is around 1131, and you can do better approximations using more decimal places. Okay, let's do a couple more examples here. I know these get to be more time consuming, but I don't want to rush you through this. I want to take time to go slowly. So the next one, very similar, except instead of given a side of the isosceles triangle, now what you're given is, I'm going to draw a line down here just to separate these. Okay, so now what you're given is the apothem. So I already know the area of my shape is 1/2 apothem 4.1 times the perimeter. That's what I'm really looking for here, is the perimeter. So if I draw in these two lengths here, I get this triangle that's already been cut in half with a 4.1 there. And seemingly that's not enough information to go on. But again, there are 1, 2, 3, 4, 5 sides. If there are 5 sides, then there's 360 divided by 5, 72 degrees in each. So there's 72 degrees in the top here, or divided by 2, there's 36 degrees on each side. So 36 and 36. Okay, so now I'm going to switch, and I'm going to say I need to use some trig here. So I don't need this length, but I do need this because I'm looking for the perimeter and the area. So I'm going to call that x, and I'm going to say, well, the tangent of 36 degrees is equal to my opposite over my adjacent. And so multiplying by 4.1, I get that x is equal to 4.1 times the tangent of 36 degrees. Okay, so let's find that out. There's 4.1 times tangent of 36 degrees. And so that's 2.978. Okay, so now it asks for the perimeter and the area. So the perimeter of my shape, let's do orange here. The perimeter of my shape is simply there are 5 sides, and each side length is 2x, right? Because x was half. So once I find a single side length, 2x, I multiply it by 5 sides in my figure. So that's 5 times 2 times 2.978. So the perimeter is, just continuing this line down here, the perimeter is around 5 times 2 times 2.978. That is 29.78. Oh yeah, because 5 times 2 is 10. So 29.78. So that's one answer. And now the area, which we already had started up above, 1/2 times the apothem times, and now we've got the perimeter, 29.78. We get that is 1/2 times 4.1 times 29.78 is 61.049. 61.049. Let's round that off to a nice whole 61. Okay. And again, we got the perimeter up here. Okay. So let's do just a few more problems here. I want to really take time so you guys get your practice in. Okay. Any questions answered? So, let's see. Oh, this is a good one. So you just have the other. So they're doing the same thing in each, except they're giving you a different length in each. So right away at the beginning, I could say, well, my perimeter is, and so I've got, let's see, 1, 2, 3, 4, 5, 6, 7. So the perimeter is just 7 times 9. So the perimeter is 63. Okay, so it was really easy to answer one of the questions. And the area is just 1/2 AP, so it's 1/2 something times 63. So all I got to do is find the apothem and we're done. We're already halfway done here. So let's look at this. We got, taking this down, we're starting with this triangle. Okay, Isosceles Triangle, which we're going to cut in half. The base is 9. And then, of course, because there are 7 sides, sorry. Because there are 7 sides, I know that 360 divided by 7, oh, it's not going to go in nicely, but 360 divided by 7, I know that each one of those is 51.428 degrees. So 51.428 degrees. So I'm going to split that in half, right? And so the triangle I'm really going to be dealing with is going to be, oh, that was a terrible triangle. Let's try that again. The triangle I'm really going to be dealing with is half of that. So I got 4.5 here is half of the base. I've got my height that I'm going to look for. That's my apothem. And then half of this is going to be, so divided by 2. So around 25 or 26. So 25.714. So 25.714 degrees. Okay, I'm not going to round till the end of my problem. So the apothem I'm looking for here is the tangent of that 25.714 degrees is equal to opposite over adjacent. So here I'm going to multiply by h on both sides, because I always multiply whatever's on bottom. And so now I have h times the tangent equals 4.5, but the tangent to 25.714 degrees is just a number. So it's just like 3x equals 6. I'm just going to divide by that number to get h by itself. So I'm going to divide by that tangent of 25.714, divide by the tangent of, 25.714. So what we get is the height, or the apothem. The height of that single triangle is whatever 4.5 divided by this tangent is. So tangent to 25.714. Okay, so let's pull this over. Let's go. We got 4.5 all divided by the tangent of, oh, I forgot the number. The tangent of 25.714. So 25.714. All right. Ooh, that's a decimal. Let's try that. Get out of there. There we go. So we got 9.344. Okay, so 9.344. Just double checking. Yeah. Okay, so that is our apothem. So now we go back up to our formula, and we've got that the area is 1/2 my apothem, 9.344, times 63, which was the perimeter we found at the beginning. And then we get that the area is around. I'm going to round it to a nice whole number. So I'll say it is 1/2. Whoops. 1/2 times 63 times 9.344. And we get around 294. Perfect. Okay, so the last one is just a multiple choice one just to throw in there. Which expression gives you the apothem for a regular dodeca? Deca would be 10. Dodeca is 12 sides. Okay, with a side length of 8. Okay, so we've got bunch of sides. So we're going to need this central angle. We know the side is 8. And so if there are 12 sides, then we've got 360 divided by 12 triangles gives me 30 degrees in each. Okay, so that was part of the battle. So we go, this is 30 degrees. Okay, so pulling this off to the side, we've got, I'm going to flip this over a little bit. We've got a 30 degree up top that we're going to split in half, 15 degrees on each side. We've got a base that had 8, and we're going to split it up into 4 and 4. So if we want to find the apothem, that's going to be the tangent of 15 degrees equals the opposite 4 over the adjacent A, multiplying by A on both sides. We get A times the tangent of 15 equals 4. Then dividing by that tangent, we get that the apothem's length is 4 over the tangent of 15. So that would be the apothem right here, 4 over the tangent of 15, or option B. So I hope that helped. That was I took a lot of time to do some nitty-gritty algebra there that maybe usually I kind of gloss over. And it's because the biggest part of this lesson is using that Pythagorean theorem or trig, just like how I did in these first examples, to say how do you find missing side lengths, the missing height, how do you find the area of this triangle? If you can do that, then this section's pretty easy, because it's just what's the area of one triangle times the number of triangles, or maybe easier for some people, just that formula. 1/2 apothem times perimeter. Hope you enjoyed the video. Good luck.